Hey guys, welcome to our notes 3.1 implicit differentiation. Up until now, we've only taken derivatives of functions in function form, y equals some function of x, but sometimes we don't have functions that can easily be expressed in that function form, and therefore we use a technique called implicit differentiation. So this week we'll discuss this more in class in depth. But let's get into some examples. So we want the derivative with respect to x of this conic section. I know this is a circle with radius 2, with the center at the origin. And so this is asking for the derivative of y with respect to x, which is the slope of the tangent line at any given point on this circle. So this equation, if I tried to solve for y, ultimately I would take a square root and I would have the positive square root and the negative square root, and there would be a lot more work. So we can use implicit differentiation with this type of equation in order to simplify and solve it quickly. So first I'm going to take the derivative of x squared. So the derivative of x squared is 2x. And then remember, I'm taking the derivative of x with respect to x on the end, chain rule. We don't normally write this because that's just 1, but that's ultimately what's happening. If x is the function that's being squared, the derivative of x with respect to x is 1. Plus, now y squared is its own function. So I'm going to take the derivative of y squared, which is 2y. But now remember, I have to do that chain rule, derivative of what's on the inside, times the derivative of y with respect to x. And that is equal to the derivative of 4, which is 0, since it's a constant. So now I need to figure out what is dy dx. So first, dx is 1. I don't need to write that, and I won't write that anymore in any of the future examples. So now first, to isolate dy dx, I'm going to subtract 2x. 2y dy dx equals negative 2x. And now to isolate dy dx, I'll divide by 2y. dy dx is negative x over y. So that means for any coordinate here on the outside of this circle, the slope of the tangent line is negative x value divided by y. So for example here, this point is the point 0, 2, x is 0, y is 2. So let's see. And this should be dy dx, sorry. Just caught that. So dy dx equals negative x, which is negative 0 over 2. 0 divided by 2 is 0. And we can see here from the picture that the slope of that tangent line at that point is 0. But now the slope of the tangent line is in terms of both x and y. So let's practice another example in the next video.